Good morning. Today we are going to learn about quadratic equations. We've been doing that, but we're going to learn about graphing them, what their graphs look like, their shapes, properties. While numbers will be involved, there will be very little math today, actually, but I'm going to teach you some very key vocabulary words. But it's not just straight vocabulary. It's also concepts. It's the properties that all quadratic equations will have when you graph them. There will be a certain shape. It's called a parabola, and it is the shape that is probably the second most important shape that you learn in algebra. The first one being a line. We do linear equations. Now we're going to be dealing with second-degree polynomials and graphing them, otherwise known as quadratics, the shape being a parabola. Without further ado, let's move on towards lesson 8 in module 4. Now, today we're going to stick to kind of closely. We're going to do some examples out of the book, so you can follow along in your binder if you wish to take notes there. Otherwise take notes. You can take notes on scratch paper, and you can learn. You don't need to have your binder. I'm just letting you know that I'm going to kind of follow some of the examples there. So the first point is that we are dealing, this here on the left here, this is called the shape of this graph is a parabola. It's called a parabola. And they can be right side up, kind of like this one, or they could be upside down. We'll look at those in a little bit, but let's talk about what this is. So let's remind ourselves what a quadratic equation looks like. And it's basically a second-degree polynomial. So, for example, I could say x squared minus 4x plus 5, and that's a quadratic expression. If I wanted to turn this into a quadratic equation, I could write it like this: y equals x squared minus 4x plus 5, or I could write it like this. And we've learned about this thing called function notation. And don't let this thing confuse you. All that's saying is it's basically saying the same thing as this, except it's also telling you that y is a function. So in other words, if I put in any given x, I will get out a unique y. I can't put in an x and get out multiple y's. If I make a t-chart and I put in x here and I put y here, this is also the same thing as f of x. If I put a 0 in up here, I will get a 5 for y. If I put a 1 in for x, 1 minus 4 plus 5 is 2, right? Et cetera, et cetera, et cetera. If I put an x in, I can always get out a y. That's all this special f of x is saying, and I remind you of it because it's used in the book, in the binder a lot. Okay, let's get back to what we're talking about. So again, where we've come from is we dealt before we got into AM4, we were dealing with, remember, linear equations. And linear equations all looked like y equals, 2x plus 4. And notice that when we deal with quadratic equations, we're simply adding another type of term here. We're going to add an x squared. So we basically are taking like kind of this linear equation piece, and we're adding this x squared piece. So if we wanted to turn a linear equation into a quadratic equation, we just say y equals, and we could add like 3x squared plus 2x plus 4. And now this becomes a quadratic equation, and it takes on a different shape. Remember, all linear equations were lines, right? If we graphed them, they'd either look like, you know, like this, or they'd look like this. And now we're going to deal with quadratics. Okay, so that's a lot of background. Let's start to talk about what quadratics can look like. Well, the first thing, one thing to notice is that they have this thing called, and I don't know if you can read this. This is called the axis. I'll write it again. The axis of symmetry. Right? And this here is the parabola line, and it keeps on going. It could have an arrow like this, like we do in linear equations. It keeps on going forever. But if you notice, there is a mirror. It's a line. It's called an axis of symmetry. It could be called a line of symmetry. And if we draw a line right here, it's basically, imagine this was a mirror. This could be a mirror. And every point on this side, for example, let's just take this point here, has a point exactly the same distance on the other side. So from here to here, notice we go from here, that's 1, 2, 3, 4. It's from here to here is 4. So from here to here, it's also 4. If we do the same thing here and we go from here to here, we go 1, 2. From here to here, we also go 1, 2, and so on. So and that's true for every single point along this entire right side or left side. I can always mirror the point, and that's going to come in. That's going to come in handy on some problems that we talk about later on. Let me just erase some of this stuff here so I can do a little bit more writing. Okay, what else is interesting about a parabola? Now, on this parabola, notice that we have some x-intercepts. Remember what, just like on a linear equation, we had x-intercepts. We had an x-intercept. Right, so let's look back at this linear equation right here that I'm drawing down here. We had an x-intercept right here. X-intercept. And then we also had what we call a y-intercept. Okay? And we have the same thing on a parabola, except notice what you have. How many x-intercepts do we have? In this case, we have one right here, and we have one right here. Why do we call it an x-intercept? I'll spell it all the way out, intercept. And then I'll shortcut it. From now on, I can use this x-int thing. And we have another x-intercept right here. So a parabola can cut the x-axis in 2 places. And it turns out that you can actually have 0, 1, or 2. But we're going to be dealing today with examples where we always have 2 or almost every example will have 2 x-intercepts. So you can think about the case when a parabola may never touch the x-intercepts or the x-axis, and you can think about maybe the case where it touches it exactly 1. But for purposes of today, let's not worry about that. Let's just worry about let's just talk about this shape on this graph in particular right here. So we've talked about some key points, and let me just call those out, right? We've talked about the axis of symmetry. We've talked about x-intercepts, and we can have 0, 1, or 2. Now let's talk about this other interesting point. Let's look at this point right here. Let's make this one in, we'll go back to blue. And we have this interesting point right here. And there's a lot of interesting things about this. This is called the vertex. And this is going to be my third star, the vertex. The vertex is always at the top. So let's see. It's always on the axis of symmetry. Always. Okay? So that's a huge, huge point. So this is kind of like point number 3 in 3A, right? So the vertex is a vocabulary word, but you need to know that it's always on the axis of symmetry. So there's another characteristic of it, and here's characteristic number 2. It's always either the maximum or minimum of the graph. So in this case, it's the minimum, right? In this case, we have the vertex being a minimum. Because it's the lowest point of the graph, right? That everything appears above it, and this is the lowest. So the vertex is always the maximum or the minimum of the graph. Okay. Point number 3 about the vertex. And this has to do with interval. Okay, we're going to talk a little bit about increasing and decreasing intervals on this graph. So let me just write this down. Well, let's just look over here at this linear equation. So on a linear equation, remember all functions either are always decreasing. So this one here is always decreasing. Always decreasing. Because it goes from top left, it's always down, 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 down. Now, the interesting thing about a parabola is it increases on one side of vertex and decreases on the other side. So can you tell me on this graph here, just take a look for yourself and decide if we're going from left to right, are we decreasing and increasing, or are we increasing and decreasing? Well, the answer is on this left side, we're always decreasing. And on the right side of the vertex, we are increasing. Okay? So that's key. The vertex divides the increasing and decreasing intervals of a graph. Okay. So we have all this written down. So let's do, we're going to do one last, now we'll do this other thing. We're just going to move on. So keys are, so the keys from this page, again, are, vertex, x-intercepts, axis of symmetry. All right, we're going to move on to point number 2. So we're going to look at 2 graphs here. And we have, these are both parabolas. Now, notice that these are skinnier parabolas in a sense. Let me just show you what I mean by that. We have, I'm just going to draw some real quick sketches over here of a parabola with the same vertex. That's a skinny one and a fat one. And these aren't perfect parabolas, so just pardon my drawing. So here's a parabola, and here's a parabola. And I could have done them in different colors. And this is kind of like a fat parabola. And this is a skinny parabola. And these, the interesting thing is, they have the same vertex, right? So you can have two parabolas with the same vertex, but different shape. Well, they're both parabolas, but they have a different quality of their shape. And the interesting thing is they'll have different equations, of course. These two parabolas have different equations, different shape, but they have the same vertex. So notice that's an important point. You're going to need to know that, I think, on the homework set. So let's just erase all this, and that we'll come back to this. Or that's a point that you'll have to remember, I should say. Okay, so let's look at this graph, and let's just graph some points. So we're going to graph this guy, and so we're going to fill in 0, 1, 2, 3, 4, 5, and we're going to graph f of x, which is also the same thing as y, right? These are the same thing as y. So at -1, we are at 8, right? -1, 8 is a point on the graph. 0, 3, 1, 0, 2, -1. This is our vertex. 3, 0, 4, 3, and 5, 8. Now, what I want to point out that is interesting, see if you can notice something interesting about this pattern right here of our y's. And for those of you who noticed, you have this kind of symmetric pattern. 8 and 8. 3 and 3. And 0 and 0. And then -1. Right? And why is that true? Well, if I look and I take my axis of symmetry, I'm going to have my middle point at 2, 1. And if I go 1 away to 1, 0, and then 1 away on the other side, I get 3, 0. Right? So these 2 points are my mirror points. If I look at, right, that was point 1 and 3. Now if I look at 0 and 4, I go to 4, 3, and I'm looking at these 2 points right now. 4, 3, and 0, 3. I'm 2 away from my middle. This is my middle. I'm 2 away on the left, and I get to 3. And I'm 2 away on my right, and I get to 3. And same thing, if I go 3 away, I get it 5, 8. I'm 3 away, and I'm 3 away. So there's all my mirror points, right? So my axis of symmetry is x is this line, and I'm going to write this down because you need to remember this. We learned this before in linear equations, but an axis of symmetry is a vertical line. It's this vertical dashed line right here. And vertical lines always have the equation x equals something. X equals, we'll call it x equals b. And in this case, it's x equals 2, right? Our line, our axis of symmetry, crosses the x-axis at x equals 2 because it crosses x-axis at x equals 2. That makes this the formula, right? Every single point on this line is x equals 2. Okay, so we talked about our axis of symmetry. Our vertex here, I did call it out. So our vertex is 2, -1. And we talked about our how our points reflect across the axis of symmetry. What is the, so ask yourself now, does this have a minimum or a maximum? Min or max? Well, this is the point that the vertex is always at the minimum or the maximum. So this is our minimum because it's the lowest point. Our maximum is, there is no maximum because these go on forever. They go on to infinity. So there's no max. So now what I'd like you to do is stop the video and try and fill out this chart here. Okay, so stop the video and fill chart. All right. Pause. Now, I assume you're back now. So let's just go ahead and fill this guy out. And we're going to go -4, -5, -1, 0, -2. So here we go, -3. So this is 3. So -1 should be 3. 0 is 0. -4 is 0. -5 is -5. Okay, good. Our axis of symmetry is right here. So our axis of symmetry is x equals -2. Our vertex equals -2, 4. And remember, the vertex and the axis of symmetry share a common thing, and that if x is -2, then my vertex has to have an x equals -2 because it's on that line. So do we have a max or a min? Here it is. This is our top. So our vertex is our maximum equals -2, 4. Right? Our vertex is a maximum in this case. Okay. And we have our mirrors, right? Our mirror points. These are 2 away from the axis of symmetry. These are 3 away. And these here are 1 away. Right. So we have our mirrors. Okay. Now, one thing I want to ask you, and this is important too, is I want to look at a rate of change. And I want to compare this. This is the same thing. So we're going to talk, this is the same thing that we do, rate of change. Now remember, when we dealt with a linear equation, the rate of change was constant. The rate of change constant for linear equations. Right, so we would have like an x and a y, and we'd have x is 0, y is 1, x is 1, we'll just do this, 3, and this would go 3, 5, 7. And the rate of change for a linear equation was also called the slope. So we would find delta y over delta x, and we could take any 2 points. So we could take these 2 points and these 2 points. So my delta y is 3 minus 1, or 2, and here it's 1. So my delta y over delta x would be 2 over 1. I could have also taken these 2 points. And my delta y here is 4, and my delta x is 2. So 4 over 2, and that equals 2 over 1. So it didn't matter which points I took on a linear equation, my slope was constant. Okay. So we're going to erase this for a second, and I'm going to keep up our same definition, delta y over delta x. The rate of change on a parabola mutates. It changes. So we can talk about the rate of change, but we have to talk about it on a given interval. So the rate, let's find the rate of change on the interval -5 to -4. Okay, so from -5 to -4, we have to go from, we'll go delta y over delta x equals 0 minus -5, 0 minus -5 over -4 minus -5. And that equals 5 over 1, which equals 5. And so we're looking at our slope, kind of our average slope from here to here. Now, and I can look at our average slope also on the interval from, let's say, from -3 to -2. So from here to here. And here I would go 4 minus 3 over -2 minus -3. So that's 1 over 1. So on my interval from -3 to 2, here's my average slope here. My average, my rate of change equals 1. My rate of change here is equal to 5. And that's just my average, because this isn't a straight line, but from here to here, I can kind of approximate it. And that's the way that we find rate of change. Okay, so let's look for a second at, let's see. Okay, so that's pretty much what I wanted to talk about today. I want to do one problem that is kind of like one on the homework. And this is hopefully kind of fun. It's, let's see here. Okay, so it's here. Here, the question is, I have half of a parabola. What does the full parabola look like? Okay. And I know, and so if this is half of the parabola, I know that this is my let's start here. Let's identify the vertex. So let's see, let's identify the vertex. And that's right here. So the vertex is 0, 3. Now all I got to do is I say, well, I can identify the axis of symmetry. Well, that's right here because it goes through the vertex and it's a vertical line. Well, now that I have the axis of symmetry, I just mirror my points. So let's mirror this one. We'll mirror this one. We'll mirror this one. And we'll kind of sketch that in. Voila! So I hope this was a useful exercise. Let's see here. I got to get back to my. Here we go. There we go. All right, coming back. That's it. That's lesson 8. It's the shape of parabolas. We talked about vertex. We talked about axis of symmetry. We talked about minimum, maximums, increasing intervals. finding the rate of change, x-intercepts. Next video, we are going to talk about how you use the math to be very precise about drawing and graphing your parabolas when you're looking at equations. Okay. Thank you. Talk to you later.